Okay, Math 12A. I've gotten quite a few questions about this. So I think I'm going to cover them all. If I miss one, please let me know. I'm going to do 1, 3, 9, 12, and 13 from the homework. So 1, 3, 9, 12, and 13. The other thing I want to do is on Wednesday at 10 o'clock. Wednesday at 10 o'clock, and I'll put this in Google Classroom too. Wednesday at 10 o'clock, I'm gonna try, I haven't tried it before, so I don't know how it's gonna work, but I'm gonna try on Wednesday at 10 a.m. because that's sort of our regular class time, to do a video call with the class. Now, if you don't think you need to be there, that's fine. You don't need to be. But if you have questions, if there's things I'm not answering, things you want to know, things you want to ask that you haven't, that's kind of hard to ask via email, then Wednesday at 10 a.m. We'll try a video thing with Google Hangouts and see how that works. I haven't tried it. My internet is not great. But we'll try and we'll see what happens. Okay, so that's Wednesday, 10 a.m. Wednesday, 10 a.m. We're gonna try that. Oh, and here comes Gabby. Come here, Gabby. Gabby's come to say hello. She went for a big long walk today and now she's tired. All right. So we're gonna do, like I said, 1, 3, 9, 12, and 13. I think that's the numbers that I saw. 1, 3, 9, 12, and 13. We're going to go over those. Again, we will try Google Hangouts. We'll try that at 10 a.m. on Wednesday, okay? And maybe Gabby will come too. All right. So, number 1 on page 431 looks like this. It has a circle, it has a center, it's got this, it's got this, it's got this. It says this is 12, this is 13, wants to know what this one so is. For this, one of the theorems was that a tangent line, which is what this is, because if you keep going, it only touches the circle in one spot, and a radius, which is what this is, are always at right angles to one another, which means that's a right angle triangle. So I would do Pythagorean theorem for this. X squared plus 12 squared equals 13 squared. So x squared is equal to 169 minus 144. So x squared is equal to, I think that's 25. And so x would be 5. That's what I would get for number 1. I think the other one, if I'm trying to remember because I read a bunch of different messages, I think another one that I read was 3. Number 3 has a circle, and I'm trying not to make the circle too big here. Has a circle, it has a center, it has a line going out to the edge of the circle and a 5. It has a line coming here. This is 10. And it wants to know what this is. Now there is another piece here, but honestly that other piece doesn't actually even matter, because again they're asking us for this line right here. Again, if this is a radius and this is a tangent, those are at right angles, so I would use Pythagorean theorem. That this time is the hypotenuse, so I would do 5 squared plus 10 squared is x squared. So that's 25 plus 100, so that's 125 is x squared. And so x is whatever the square root of 125 is. And you can put that in your calculator, but I do have it right here. Didn't think I did, but I do. Square root of 125 is 11.2. So x is 11.2. All right? All right. So that was 1 and 3. And then the other ones, I believe, were 9, 12, and 13. And some people said I didn't get this angle or I didn't get that angle, so I just thought I'll do them all, and that should work. So number 9 looks lovely. It's a circle, and it has the center of the circle, but it has a line that's not going through the center of that circle. It has a line coming up here, one coming down here, one here, and one here. They tell you that this is 105. They put a tangent line coming here. They tell you that this angle is 45 degrees. And they want to know this angle, we'll call it X, they call it number 1. And they want to know this angle, which I'm going to call Y, they call it number 2. So again, some thinking about what some of those theorems say. I'm going to figure out Y first, just cause. In a cyclic quadrilateral, which this is, all the edges are at the edge of the circle, making it cyclic. Cyclic just means in a circle. And quadrilateral meaning 4 sides. And one of the theorems said that opposite angles are supplementary. In other words, they add to 180 degrees. So 105 plus Y would have to be 180. So Y would be 180 minus 105, which I think would be 35. So I think that one's 35. Now, I have to figure out this one. How am I going to do that? Well, there's a tangent line. Let's see. There's a chord, and it says that the angle is equal to the angle opposite the chord. So I think this one would be 45. I think, which would mean if this is a triangle, 105 plus 45 would be 150, and the whole triangle, this and this and this, have to add up, so 180 minus 150 would be 30 degrees. So I think X is 30 degrees. Now I'm going to double check because, hey, I can be wrong too. So I'm just going to double check my answers. I'm never as confident in this section as I should be. So this is 7.5, number 9. Yep, 30, and number 2 is, oh, they say number 2 for number 9 is 75. So what did I do for number 2? So just a second, they say, whoops, they say for number 9, 2 is 75, and I said, oh, it's just because I can't add, isn't it? Hopefully you were yelling at your screen saying, it's just because you can't add. 180 plus 30, yeah, that's not it. 75. Should be 75, okay? And that's just my math. That has nothing to do with my logical reasoning. It has to do with my really bad mental math skills, doesn't it? All right. My black marker appears to be running out of ink, so I'm moving to blue. All right, so 12 and 13 were the other two that I seem to repeatedly get questions on. Again, some people said I couldn't get this angle. Some people said I couldn't get that one. So we'll just look at all of them and see. So we have a circle. And I'm going to have to do this line by line. So there's a line there. And there's a tangent line. It's a bad tangent line, but just pretend. There's a line here. There's a line here. The center of the circle is like here. There's a line here. Whew, there's a lot of lines. And a line here. Okay, and they tell us what? They tell us this angle right here. I'll put an arrow to it. That angle is 51 degrees. And that's the only angle they tell us. And they want to know this angle, which they call 1. I'm going to call x. They want to know this angle. They call it 2. I'm going to call it y. And they want to know this angle, which I'm going to call z. They call it 3. I still do it basically in numerical order. I just do it slightly differently. So let's see if we can figure out what is going on here in number 12. So in number 12, let's see. This is a tangent line. This is a chord because it's going from one edge of the circle to the other edge of the circle. So that's a chord. That's a tangent line. An angle between a chord and a tangent line is the same as the angle that is opposite the chord. So if this is the chord and I go opposite, it looks to me like x should be 51 degrees because there's the angle between the tangent line and the chord. The angle that is opposite the chord is this one. So this angle and this angle have to be equal. That's one of those theorems we talked about. All right, so I'm going to fill that in with 51. All right, so I'm going to use some logic from way back on this one. First off, I'm going to look at it this way. This is the center. The center is going out to this point and this point, meaning it is subtended or it is joined together by this part of the circle, right? Because the central angle comes out to here and here. So it's subtended by this. And we know that that's 180 degrees because it's half of a circle. It's a straight line. So it's 180 degrees. This angle up here is also comes out to here and here, meaning it is also subtended or joined by this red piece of the circle. This angle, though, is at the edge of the circle, so it is an inscribed angle. And there is a theorem that says a central angle that is subtended, that is joined by the same arc as an inscribed angle, the central angle is 2 times bigger than the inscribed angle, which means that this angle right here has to be 90 degrees because it has to be half of 180. Now that's not actually an answer, but that's okay. Because what I'm going to do is I'm going to use that to figure out angle Z, because Z plus 51, this one down here, plus 90, this one here, should all equal 180 degrees because that's a triangle right there. And all angles in a triangle add up to 180. So 51 plus 90 should be 141, and that's 180. And so Z is 180 minus 141, which I think should be 39. Please let me be right. Ah, yes I am. That's good. So I think Z is 39. Again, nothing says that you have to figure out like number 1 first, number 2 second, number 3 third. You don't have to do that. It doesn't matter. All right. So the last one I have to figure out is Y, and I already know what it is, because thinking back again to those rules about inscribed angles, this 39 degrees is an inscribed angle. It is an angle that is at the edge of a circle. And if I follow this inscribed angle, it comes out to this point and it comes out to this point, meaning it is subtended or joined by this green arc. And so for Y, it's also an inscribed angle, and it also comes out to this point and this point, meaning it is also inscribed by this green part. Two inscribed angles, two angles that are at the edge of a circle that are subtended by the same arc, they are equal. And so Y would also be 39 degrees, simply because it has to be the same as this one, because this comes out to these 2 points and this also comes out to these 2 points. So that's how I would do number 12. Again, may not be the only way, and if you say, listen, I got the right answer, but my logic was slightly different, if you got the right answers, your logic was probably right. It's very unusual for you to guess the right answer with the wrong logic. So, number 13. Number 13. Gotta go back, hold on. Let me find it again. Number 13. Oh, I don't know how I'm gonna do with this one, guys. All right. Sorry in advance. So we have a circle. Sorta. And we have a line coming here, so that's a chord. We have another chord here. We have another chord here. So we have 3 chords making a triangle. Sometimes as you draw it, you can see things because you don't have all those lines in the way, right? They're gonna ask us about what this angle is. So they draw a tangent line, but they only draw like that half of it. They don't draw this half down here, but it's still a tangent line. It's only touching the circle in one spot, and they're going to want to know that angle. And then they draw another tangent line here, and they're going to want to know this angle. So let's call this. This one's number 3, so this is number 2. Let's call this B and C and D. And okay, they draw this tangent line all the way out here, and they draw a line from here out to here. Now this is not a tangent line because it's not just touching the circle in one spot, it's actually actively going through the circle, therefore that's not a tangent line. It's also not even a chord because it doesn't just go from one side of the circle to the other, it keeps going out. So that could be a little bit tricky. They want to know what this angle is. They tell us that this angle is 73 degrees. They tell us that this angle is 30 degrees. Clearly I did not draw this very well. And they tell us that this angle is 37 degrees. The center of the circle is kind of right here, so there's no line going through the center of the circle at all. All right, so we have to start figuring out some angles here for number 13. And again, do what you see first. Whatever you happen to see, do that one first. I actually happen to see A first on this one because to me, when I look at this, I'm seeing a triangle here, all right? I'm seeing a triangle. I'm seeing that I have a 30-degree angle. I have a 73-degree angle, so I can figure out what A is. Because A plus 73 plus 30 is going to have to total 180 degrees. And so A is just going to be 180 minus 30 minus 73. And with my earlier blunder, I'm going to make sure that I get it right. It is 77 degrees. And The book agrees with me. All good. All right. So I got A. That doesn't necessarily mean that that's actually going to be the next one I get. In fact, I think I'm going to get C next based on what I'm looking at. Let me think. All right, this is a tangent line. And so this angle is going from a tangent line to a chord. This one's not, because this isn't a tangent line. This one is. It's going from a tangent line to a chord, and they're saying it's 73 degrees. And the theorem says that angle is equal to whatever chord it's touching, the angle opposite it. So I would say that C should be 73. Now again, let's check and see whether or not my logic is sound. If I look at number 13, number 3, they do say 73, so yay me. All right, so they're saying that C is 73 degrees. Okay. I don't know what B is, but I think I know how to figure out B, because again, B is from a tangent line to a chord, which should be, and it's this chord that it's touching. The angle opposite that chord is 37. So I think B should be 37 degrees. And the book agrees with me again. Yay. So I think B should be 37 degrees. Again, because of that theorem that says the angle between a tangent line and a chord is equal to the angle that is opposite that chord. All right? So if B is 37 degrees. All right, now I have to figure out D. And maybe you've already figured it out. Maybe you haven't. I haven't. But I think I know how I'm going to get there. And again, I think probably there's an easier way to get there. And maybe you're yelling at your screen now saying, I know how to do this. But here's what I would do. Here's what I would do, okay? If I continued this tangent line, remember I said it could continue? If I continued this tangent line, I can figure out what this angle is, because that would be 180 degrees, and that's 73 and that's 37, so I can figure out what that is, because I can do 180 minus 73 minus 37 leaves me with 70 degrees. This angle is 70 degrees, and that's going between a tangent line and a chord. That is equal to opposite the chord, which is 70 degrees. Now, I can even check that because that's a triangle, and it should add up to 180. So if I do 70 plus 73 plus 37, please be 180. It is. So I didn't even need to figure this out because I could have just figured out the 70 anyway. If I know that that is 70, again, this whole thing would have to be 180 because that's a straight line right there. So 70 plus 73, which means this is going to have to be 37 degrees. So now if I look at this little triangle up here, right here, if that's 37 and that's 37, and I know that all three angles have to add up to give me 180 because it's a triangle, 180 minus 37 minus 37, I get that D should be 106. And again, I think I went about that probably the hardest way possible. I think there was probably an easier way to think about that. But that's where my mind went. Again, so what I did to show my work was I filled in what I was figuring out so that if someone was trying to see where my thought process was, the only thing I should have probably done on D was do 180 minus 37 minus 37 so that someone knew what I was doing. But really, there's not a whole lot of work to show. again, if you know your theorems, you're gonna reason it out. You're not gonna pick 106 out of your hat somewhere. If you get 106, it's not from guessing, it's because you knew where that came from. So I hope this answers some questions. I keep trying to repeat the theorems over and over again to kind of stick them in your brain a little bit. Again, if we were in class, I would be getting you guys to repeat them to me all the time. So if you are getting lost, at least 1 or 2 people have said, I am confused on this section. Again, we will try Google Hangouts. I assume that if I hit the little video thing, it will call all of you. If you choose to answer, that's great. If you choose not to and you feel like I really don't need to, I don't have any questions right now, that's fine too. You are in no way obligated to. But if you want to, 10 a.m. Wednesday morning. Okay? We'll talk to you then.